Thank you so very much. Welcome to the Churchill Club. My name is Karen Tucker. I'm CEO. And our program this evening is called Augmenting Human Intelligence, AI and the Future of Cognitive Computing. With all the buzz about AI, how best to separate fact from fiction, how are emerging cognitive computing technologies already integrating into business and society, and how will they evolve over the next decade? And what future applications hold the greatest promise? There's no better trio to explore these questions tonight and more. As head of IBM Research, John Kelly is the father of Watson, the Jeopardy-winning technology that is now tackling cancer, financial markets, and oil exploration. And the Universite de Montreal's Yoshua Bengio is widely considered among the world's foremost experts on machine learning, an essential element of any true AI system. And Pulitzer Prize-winning reporter John Markoff of the New York Times has followed developments in the AI field for over 2 decades and just released Machines of Loving Grace, the quest for common ground between humans and robots, to broad critical acclaim. Before we call up our speakers, some thanks are in order to our member and partner IBM, in particular Vinita Durrani, for her assistance and support in creating this program. Thank you. A few words about Churchill Club for our new guests in the audience. We are a nonprofit technology and business forum devoted to encouraging innovation, economic growth, and societal benefit. We ask our speakers to come to the stage to advance collective understanding and shine a light on implications of trends they see today for opportunities tomorrow. This, we hope, in turn, will inspire listeners to take positive actions themselves. And we've been privileged to convene people with one another and important new ideas since 1985. Next up, on October 29 in Palo Alto, we address cybersecurity with the CEOs of Fortinet, Palo Alto Networks, Symantec, and Intel Security. In the evening of November 10th, something different, at Santa Clara University, we present the Oscar-nominated actor James Caan with life and business lessons from the Godfather movie trilogy. The morning of November 18 in Mountain View, we have Stanford President John Hennessy and UC Berkeley Chancellor Nick Dirks with their views on the future of higher education and what's at stake. For more on these and other upcoming Churchill programs, you can find all of the latest information at churchillclub.org and also our newly launched website, churchillclubforgood.org. If you tweet tonight, please use the hashtag Churchill Club, and you will find other Twitter pointers in your programs. So let's now give a very warm welcome to Yoshua Bengio, John Kelly, and John Markoff.
Good evening, everyone. Start thinking of your questions, because we're going to talk for a while, and then we're going to open it up to the House. Since its inception in the 1950s, the field of artificial intelligence has overpromised and underdelivered on a really remarkable scale. And where we are now is really quite remarkable, because about a decade ago, things started to change. John likes to say it's only 5 years ago, but it was 10 years ago that Stanley, the Stanford autonomous vehicle, won $2 million from the government, from DARPA in particular, for a self-driving car contest. And since then, there's been this really remarkable acceleration. The self-driving car contests were a harbinger of a whole series of things that have happened since. And we're on the cusp of this period where machines which once replaced brawn are now increasingly replacing the human mind. And that's what we're going to talk about tonight. But I actually wanted to start at the very bottom of the stack and work our way up. Because in the last couple of weeks, just very recent weeks, IBM has kind of embarrassed me, because I've been working on killing off Moore's Law for almost my entire career.
We're not gonna let that happen, John.
If you have a good story, you're supposed to write it frequently, which I've been doing. Two announcements from IBM recently with respect to the state of progress and the rate of change in semiconductors that I wanted to ask you about, because the brick wall is now sort of at 5 nanometers, which we're supposed to reach somewhere after the turn of the next decade, but maybe not. And so if you could talk to us, I mean, you announced a working prototype and then you announced a new technology, and it suggests that maybe there isn't an end in sight. How optimistic are you?
Well, great question, John. I'm very optimistic. The first thing we announced a couple of months ago was that we had built a full working prototype at 7 nanometers. Full EUV lithography, very, very sophisticated compound FinFET device, which proved, to the world that 7 nanometers was very, very doable and really would produce a roadmap towards 5 nanometers. And then we, in parallel, and we have all these programs running in parallel, but beyond silicon, it's pretty clear to us that some sort of a carbon device will be the next generation. And we've been working very extensively in carbon nanotubes. And we've been able to produce working devices, switches, working circuits. And again, a couple of weeks ago, we announced that we had solved one of the fundamental problems in putting together carbon nanotubes. And then sort of on the back of that, or I guess it was just before that, the next generation technology, really the holy grail, is quantum computing. And we have built the world's most coherent 4-qubit device, which is the fundamental building block of a quantum computer.
Which will factor, 21 at this point? What will
which will factor, for the people in the audience, think not like 2x or 10x, think like 10 to the 20th times the performance of today's computer. It's something we can't even begin to comprehend. So for factoring of certain kinds of problems, it's going to be absolutely incredible. So our view, John, is that lots of room left to push silicon-like devices that'll migrate into carbon devices of some sort while we're working on quantum. And I've never seen a more exciting time in devices than right now. And these are all different materials, and I know you take a personal interest in that.
Yeah.
Different materials, different device structures, but hugely exciting time.
There was a point where IBM was very interested in graphene, another material. Yeah. Is it still a candidate?
Still very interested in graphene. We've produced, I think, probably the world's fastest graphene devices. They tend to be better for analog type circuits than switching devices. We believe that nanotubes have a better high performance characteristic than graphene.
So, why are we talking about this geeky stuff? One of the things that's striking, and the things about Moore's law that are no longer true, is for most of the industry, the cost of transistors has stopped falling. And sort of why we care about that in Silicon Valley is when transistors fall in cost, you get whole new industries at regular intervals. Do you think we'll get back on that? I mean, can you see the performance curve continuing or accelerating, or is it going to be slower in the future?
Yeah, the performance curve and density curve, I think, will continue. It'll have its fits and starts. The cost will be an issue, though, until we make a fundamental switch to a nanotube device or a quantum device. Because these things, I mentioned EUV lithography, these are enormous pieces of equipment, very low productivity versus an optical tool today. So, yes, we'll get the performance, yes, we'll get the density, but at what cost?
So the reason we care is the technologies we're talking about tonight, they do much better if you have more compute, right?
Right.
And sort of as a transition to that, you've worked to do new architectures, and one of them is called True North. Do you think that this shift to this new kind of computing that you're talking about is going to require new computing architectures, or does it ride on the existing establishment architectures that we know today?
Yeah, many of these techniques will ride on the current sort of roadmap, but there's some very interesting technologies, and I'm sure we'll hear about things that will, underlying hardware that will be much, much more suitable for machine learning algorithms, deep learning algorithms. An example is the Synapse chip, which is a synaptic device, which is basically replicates a large array that we program down onto and use machine learning algorithms. So those kinds of things I think will play a major, major role. Performance will be important, but power consumption will be incredibly important. You know, I always like to remind people that Watson system that beat those two 20-watt human beings was 85,000 watts of power. It took 85,000 watts of power to beat two 20-watt human beings. We're clearly doing something wrong, John.
Yoshua, are you all software? Do you care about the underlying computing environment?
I have been all software mostly, but in the last few years, realizing that the computing power was a major stumbling block, that the best models we can train are the biggest that we can train. I've started to invest more time on how could we design the algorithms so that they would fit more easily on hardware. So we've been working on variants of the state-of-the-art methods based on what's called backpropagation that could run on specialized hardware without multipliers, without what's currently taking most of the space on chips, on GPUs, which is what you're mostly using these days.
Yeah.
And so I think people like me can work with people that are doing hardware to not just take the current algorithms and try to fit them in the hardware, but maybe redesign them appropriately so that they can more easily exploit what hardware has to offer.
And the range of, take it all the way to the kinds of applications that your underlying tools, is it speech, vision? Is it broader than speech and vision at this point? What kinds of things do you work on?
Yeah, so we have done speech and vision, and I think there's a lot going on throughout the world, and we have a few projects in my lab. But the most exciting areas are new areas, in particular, everything having to do with language. So I believe that one of the big challenges and the most exciting areas of progress these days is in language understanding. And we're seeing progress there. People used to think that neural networks were just good at pattern recognition, at doing the perception part of things. And it turns out that some forms of machine learning and neural nets, especially those called recurrent networks, are making strides in this area, which used to be thought as reserved for classical AI, reasoning, symbolic computation. And being able to do that is actually very important when you start playing with language, when you want to build systems that dialogue with humans. So there's a lot of papers and groups working on this these days, including in my lab.
John, I wanted to ask you about, so IBM's made a big bet on this thing that you're calling cognitive computing. Do you want to kill off the term AI? It's a serious question. Is this the right time to get away from artificial intelligence as a...
Yeah, our view, John, is that AI is really a subset of cognitive. It's a set of tools and techniques, machine learning, deep learning, which are useful techniques, but to us, cognitive computing is a much bigger thought. It's applying these technologies to industries. It's building a platform versus a set of tools. As I look around in our industry, there are many companies that are experimenting with machine learning and using them in search algorithms or other kinds of online content. But from our standpoint, cognitive computing is really about a whole new standard, a whole new way of changing businesses going forward. It's sort of like, our analogy would be the System 360, where it was a whole new platform. It was a whole new platform for IBM. It was a whole new platform for the industry, where programmable systems now became industry standards and a way forward for businesses to do real work. So not trying to displace AI, we just view AI as a component of cognitive.
I made a little discovery, which really is quite striking to me, about AI. And, words are important, what they mean and where they come from. I was reading, when I was researching my book last year about AI, and John McCarthy is very clear about why he coined the term AI in 55 or 56. He wanted to differentiate the term from cybernetics because he really disliked Norbert Wiener. He thought Wiener was a boor and bombastic and was way too analog. He wanted to, ironically, he wanted to move things in a digital direction and a logic direction. And this term came out of an academic quarrel. which is quite striking to me. That you know, it's settled on the world, and everybody sees the world that way. I mean, do you consider yourself an AI researcher, or?
Absolutely, but I would say cybernetics is back big time.
Is back big time. Well, isn't that it never really went away. It sort of took roost in it took life in Europe, but
so it's interesting that when I started doing research in my grad studies in the 80s, mid 80s, the word AI was reserved for the symbolic AI you were talking about from McCarthy and so on, and we didn't use that word. We didn't consider that we were part of that. Of course, we were trying to build intelligent machines. But the things we were doing with neural nets in those days, we considered were descendants of cybernetics. But now, things have changed. Since the word AI is back in fashion, it actually, you know, we've taken back the word, or, you know, it's now associated closely with machine learning and deep learning and all these things.
Yeah. So we had this little discussion while we were talking about where IBM as a company is with respect to AI. There is a history that suggests that early on IBM had trouble with the concept. So 56, the field started. Nathaniel Rochester was a well-known IBM researcher who began doing research in chess and other places. And then he kind of got in trouble with the IBM sales force, apparently. You're going to check this for me.
I'm going to check this for you.
But basically, they were worried that, you know, thinking was the province of humans, and computers were number crunchers, and they didn't want the managers and supervisors thinking that they might be displaced by these machines. So right at the beginning, it was an issue for your company, I think.
Yeah, I'm going to go back and research that. I mean, I know that as I've looked back, even Watson Jr., as he talked about systems that were taking on more and more ability, he referred to them as taking away more of the menial mental tasks of humans, so that humans could move on to upper level reasoning and things. And he was very clear about that. I don't think at the time, obviously, he had any idea where these systems were going to go.
Yeah.
But he had a concept in his head that these systems were going to become more and more powerful, and didn't seem to push back.
So you're talking about cognitive computing as a platform. If you go to the dictionary, it's it's to know and to understand and to perceive, I think, are the
That's
sort
right.
of the...
And to reason over something.
And to reason, yeah. And how will you get it to customers? I mean, how do I end up seeing the cognitive computing system?
Yeah, so I think maybe one quick place to start is with Watson, we did not start out to design or build an AI system. People may think that. We set out to build a system to deal with massive unstructured data. We saw the trend going forward of the explosion of data in everything from healthcare to retail to banking, and it was no longer about decimal point accuracy. It was about getting an insight from massively unstructured data. And we realized that data was growing at a rate that we could not keep up with from a programming standpoint. It's almost a divergence of Moore's law transistors versus what humans could design, and we developed a whole bunch of EDA tools and things to help close the gap. But we set out to design a system that could deal with massively unstructured data. And in the course, the first use case we chose was natural language processing, deep Q&A, going after that, but with a thought process that we would then go on to other areas of vision and machine to machine, et cetera, et cetera. So to us, that's what the platform's all about. Building a capability that is data-centric, not processor-centric, not programming-centric. So the way we work with our clients, and we have hundreds of clients across every industry now working with Watson, it's a combination of our machine learning, our techniques, massive data ingestion, whether it's electronic medical records or medical journals or retail records or whatever, and then operating over that to produce new insights for a doctor, a lawyer, a retailer, a financial advisor. And it's not something that's decimal point accurate. It's something that gives new insight with probabilities based on the data. And when you see the precision of the system is low, you don't go in and reprogram. You get it better data, or you teach it something about the data, and then the learning takes over. Completely different paradigm than we're used to in the programmable error.
You've begun talking about APIs. Does it begin to look like an operating system in the cloud?
One could think of it that way. It's really a set of composable services that are exposed, API-like. But these are large, think of them as large Lego block systems and capabilities that are called upon and composed into useful applications.
So as a user, I see Watson through applications entirely.
Through applications and insights. You'll as a user, as a consumer, as a medical doctor, you'll see it through insights. Watson will give you an insight into something that you would not have thought of.
And when you say reasoning, reasoning sounds very much like what humans do. What does Watson look like when it reasons? How do I watch Watson reasoning?
Watson compares and contrasts all the information it has. It's always looking for patterns. It's always comparing. It's always ranking things, trying to determine what's right and what's wrong. And based on feedback, and this is absolutely critical, the more feedback you give Watson based on its decision, the faster the machine learning techniques can kick in. That's our definition of reasoning in the system.
It didn't start with, deep learning and your partnership is relatively recent machine learning was part of Watson from the beginning, but it was probably more traditional kinds of machine learning techniques. Is that true?
In the first instances, and now the number of, we built Watson in a very modular way. So we could ingest all sorts of data, but we could also bring new algorithms in and new engines in. And, when I say platform, it's not just a bunch of APIs. It's a fully coherent set of learning algorithms and techniques, AI techniques, that can be balanced and traded off depending on what the problem is. If it's a certain kind of problem, use these. If it's another kind of problem, use these.
Yoshua, what is your role are you a consultant, or as University of Toronto, is your school participating with IBM?
So I'm being funded in part by IBM, and we have a large group of students working on the cognitive computing and AI and deep learning, especially the language and speech, and also video. And we collaborate with IBM researchers on these projects.
Okay. Give us a little bit of a history of the concept of deep learning. You were involved.
Sure.
I heard that you and Jan LeCun and Jeff Hinton thought of yourself as the Three Musketeers. You talked a little bit about being outside the traditional AI world.
It really was. No, so what I was talking about earlier was in the 80s, where the first, the second wave of neural net research was considering itself outside of the traditional AI. But in the 90s, the whole research area of neural networks and it went out of fashion for a number of reasons, and I had to twist my students' arms for them to continue working on this. And in 2005, the three of us got together with a particular grant from the Canadian government, from an organization called CFAR, to start a program on what was to be called deep learning a few years later. And 1 year after the beginning of this, we already had the first things going where we broke a first barrier of being able to train neural networks with many layers, which is essentially what deep learning ends up being. And then
was that about design or hardware? What permitted you to make that next step?
Sorry?
What permitted you to make the next step? Was that new designs and new ideas or new hardware capabilities?
New design. Basically, for the first time, we introduced unsupervised learning, where the machine learns without human guidance, as a building block for training a deeper neural network that can do a particular task. And that was the first trick we found to train these deeper neural nets, which are able to learn more abstract concepts than the older ones from the 80s and 90s. And immediately we found that they worked better than the old ones. For a long time we thought that it would be great if we could train deeper networks, but we didn't know how to do it. And so we stumbled upon these results. By 4 years later, we discovered ways to do that, other ways to train deep nets, which now have become the standard. And by that time, applications started to roll in. So first speech recognition around 2010, 2011, And then object recognition in 2012, there was a big breakthrough. And then the big wave of interest from industry and the press really made things grow very, very fast.
So speech and vision, are there other areas that are on your agenda now? I mean, how
Yes.
broad can these techniques
Absolutely.
be applied?
So as I said earlier, one of the things that I'm most excited about is dealing with language understanding. Another really difficult nut to crack is what's called unsupervised learning. So the thing by which we started remains a frontier. We don't know how to train machines without a lot of human guidance to tell the machine how to interpret each image or each sentence or each sound. And we can go so far with this supervised learning where we basically have to tell the machines what the right answer should be for each case. In order to really build AI, we need machines that can observe like we do and use that to build a model of the world. That's what unsupervised learning is really about. And there are many unsupervised learning algorithms, but we still are not satisfied with how well they're doing. Now, to move forward, in 2009, the hardware really made a big difference. So that's when GPUs started to be used in deep learning. So it's thanks to that we were able to go to larger data sets and systems, for example, that could handle 1,000 object categories. So that was part of the breakthrough, but it came a bit later than the original algorithms revolution.
Is there a danger, again, of getting out in front of yourself? This year at CVPR, which is the major technical show for this technology, there were a number of papers that conjoined two different types of neural networks, and they began to do what's thought of as scene understanding, which I take to be the holy grail of the machine vision world. You could look at a picture, and it wouldn't just recognize there was a pizza, but it would say the boy is eating a pizza. You'd get a sentence out of it. But is that significant, or is it a dancing dog? Is it usable in some way that's meaningful? Was it a breakthrough, or?
I was really surprised. So in my lab, we were also working on these things. And when I started seeing what the systems could do, you show it an image, a natural image, a scene in the park, and it would say, the woman is throwing a frisbee. In English, typically without mistakes. That was really amazing. We had systems that could compute the probability for is there a woman, is there a dog, is there a tree, but producing natural language sentences that were often good. That was a big surprise. Now, I don't mean that there is an application right away, that can be using this, but you can imagine many ways that the same technology could be applied, where instead of generating just sequences of words that are English, you could, given some context, produce natural language sequence that's meaningful in that context, that to imitate, say, what humans would do. This is how they were trained, right? People were typing captions for these images, and we trained the system to imitate, but they wouldn't just copy what humans would do. They would actually generate new sequences of words.
John, have you already started, or can you integrate those kinds of technologies into and the training part? How much of that requires sort of armies of consultants and specialized hand tuning, and how much of it can be made into sort of a consumer-friendly
it's
technology?
not bad. It sort of calibrates you. When we first started with Watson in real live use cases with businesses, it would take us roughly 6 months to get Watson trained. And a lot of it is, he said, was annotating data and whatnot to sort of get the machine started. I think it was sort of priming the learning pump, if you will. We've got that down to a few weeks now in most cases. And what we're finding is that it is a bit of a heavy lift when you go domain to domain, but when you're in a domain, so, again, the healthcare case, once we're in a cancer, Watson has learned the language of cancer, and then we can very quickly go from different types of cancer. But if you then take and leap over to some other renal or something, then it's another reset. But now it's still only a month or two. It's not a 6-month journey. So we're learning, we're adding new techniques, and again, I think what a lot of people don't understand, John, is it's not just one technique to get at these things. You need to use a suite of techniques and compose it, and the machine has to know which technique to use in which instance. And that's where some of the sort of the secret sauce is.
Let's talk specifically about cancer. I mean, cancer has pushed back against the brightest human beings for a really long time, and each advance seems to be confronted with new complexity.
Yeah.
As recently as 2 years ago, I had people in the sequencing world saying that they believed that curing cancer would just be a lookup table, that you would understand where are you deploying Watson and how might it be used to advance treatments?
Yeah, well, the whole field has advanced dramatically. I mean, it used to be cancer was a disease, and then it became a disease of, lung, breast, brain. Then it became where in the body was it exactly within the lung, became a different type. And now, obviously, there's a much deeper understanding of the many different types. And there's also an understanding that tumors are morphing very, very rapidly. So
right.
What you know about a cancer is only at that instant in time. And I think people have underestimated that. So we're using Watson in a number of areas. So it's ingested basically all known medical literature on cancer. We're working with the experts at Sloan Kettering and MD Anderson to train the system. Each of them has a preference for a set of knowledge and a set of protocols that Watson takes into consideration to become an oncology advisor. Another great example, which the folks at Mayo are just head over heels on, is in the area of clinical trials. So, God forbid you're sort of at the point where you need to jump into a clinical trial because nothing else has worked. There are thousands of clinical trials, hundreds of new ones being generated every week. And every patient and every cancer is unique. It has its own tumors, its own mutations, its own pathways. And we have created a tool at Mayo Clinic that does that matching. Today it is an oncologist, a set of fellows or students that will spend, if you're lucky, a few days trying to match you to a clinical trial. Watson will do it in minutes.
Based on your genetic information, or is that part of the...
Based on your electronic medical record, we're now folding in the genomics angle of this.
Yeah.
We've got a project with New York Genome Center around brain cancer, where we're literally looking at the mutations and the tumor normal, comparing the two data sets. Typically, it's 200 to 300 different mutations that have occurred, but each one of those will have hundreds or thousands of pathways, more than any of the world's best docs can possibly figure out. And we're applying Watson against that with, again, oncologist plus machine to come up with better treatment. And we're running those experiments right now.
Have you heard the term centaur? Is that, are you familiar with that term?
No.
Well, this is apparently AIs plus humans do better than AI versus... So this would be
that's right.
a model of a centaur.
Right. Oh, I think that's going to be the case.
And in your white paper, IBM has a white paper about the technology you just published. You cite a scenario in which an oncologist envisions sitting in his office with a patient, a nurse, and a medical student and having a conversation in which Watson participates.
That's right.
I mean, how close are we to actually having the computer in the room as a conversationalist?
Very close. Some of the doctors we've been working with have been starting to do this. And what they tell us is it completely changes the conversation. That the patient is actually very comfortable with this. The patient is actually more at ease knowing that they're just not hearing this from one individual. In the end, they obviously trust their physician, but having data, having statistics around people like you and what the outcomes are is very reassuring.
And what's the user interface for Watson is not speaking and listening yet, right, in the room?
In this case, it's on an iPad.
Yeah. And will that be true for some time? I mean, at what point will Watson actually begin to participate in the conversation?
Well, we've got dialogue modules, voice modules now, and it's really almost at this point a user preference. And at this point, the doctors would like to have something to discuss the data rather than having another talking machine in the room.
Let me approach the question of the role of Watson in the medical field from another angle. I could see Watson being deployed to augment the doctor, to make the doctor smarter. That's the scenario you're talking about. I could also see Watson being deployed to remove the doctor, And, to basically take nurses or other practitioners and basically make the world need fewer doctors, because you could do a lot of triage. And I mean, obviously, in terms of the cost scenario in the medical field, that has to be a possible opportunity for IBM.
I think it's still a combination, John. I mean, I think that there are so many factors that come into a diagnosis and a treatment. There's lifestyle, there's other emotional characteristics, there's other attributes of the patient that Watson will not have a handle on. Watson will have all the data, all the statistics, all the insights of known information at the fingertips of the physician and the patient. But in cases like this, there's so much more that goes on with the patient. They're trying to make some life-changing decisions. And that, I think, is something that a human is always going to be involved in. And we always want a human between the machine and the patient in healthcare.
Okay. So this notion of a cloud OS that might be intelligent, increasingly intelligent, at what point will those APIs be accessible to researchers like Yoshua? I mean, to the research community, will they have access to these to build?
Absolutely. So we have 2 or 3 dozen now major API services that researchers, in fact, startup companies can have access to.
Give a couple of examples. What's a classic example? I mean, is this like text search or what?
You can do text search, you can do dialogue, you can do image recognition services, you can compose your own. We have roughly 100 companies now that have started to compose Watson solutions on this and can go into a run mode.
Will they touch consumers?
Absolutely. So we have everything from veterinarians that are composing, health-like applications for pets through retailers that are driving consumer insights. One of the services that you can call upon is basically a psychological profiling based on text or natural language of a person. Yeah. To try to get a deeper insight into preferences for retail or whatever. So these are all available as a service on our Watson cloud.
Now, Microsoft is talking openly or not openly about AI APIs, and the Google Brain project is starting to sound a lot like something that will be deployed. Amazon can't be far behind. We're going to have these competing intelligent OSs in the world. Is that sort of the way the next wave of competition is going to?
It could be, John. That's not the way I currently see it, at least based on what I know. I see these other companies that are using AI to do very specific things around their business model, to try to drive more intelligent search or to make sense out of images that they're storing, get better insights on their users in a very targeted way. And from what I understand, they're really trying to drive those specific engines, deeper, faster, better. To my knowledge, we're the only ones that are building a complete platform that work across all of these, that are exposing these services and saying, come one, come all. Innovate on this platform. We'll benefit financially as they do that, but we want to be the open platform for this next generation.
IBM has become closer to Apple recently. Could you see a scenario in which Siri would, through some back of the back there somewhere, use Watson services to offer?
Well, as you know, we're collaborating in a number of areas in applications. We announced a couple of months ago that the Apple devices around ResearchKit and HealthKit will all be, with the consumer's permission, uploaded to the IBM Health Cloud, the Watson Health Cloud. Huh. So we'll be able to use all the data from these devices there to pass back deeper insights to consumers.
So this will be done through the HealthKit application or through applications that people are building off of the HealthKit API?
Either way.
I see.
Either way.
So it's already happening.
It can be passed back. That's right.
Interesting.
We're firing up the cloud for that as we speak.
Yeah.
I want to mention something about the healthcare applications. The way, from a statistical perspective, the way that doctors have come to conclusions about treatment is based on very little data. A few dozen people in a clinical trial, maybe a few hundred if you bring together multiple studies. And from a machine learning point of view, this is ridiculous. This is way too small. What the result of this is the way one decides on the treatment is you have the disease, you don't have the disease. If you have the disease, you take this drug. But really, you're different from anyone else in the room and anyone else on Earth. And we can use some of those differences to very likely suggest a better treatment. Now, how do we find what's the right treatment for you? Well, that's what machine learning is for, right? We have all the technology for this with deep learning or other techniques. And basically what's missing here is a social barrier and sort of the infrastructure that would allow this to happen. The data right now is not accessible. There are privacy issues. There are companies hoarding or hospitals hoarding their data. But the pressure for bringing all that data together so that we can build better health systems and diagnostic systems and predicting the outcomes of treatment is going to, I'm convinced, is going to make things change. And furthermore, there's, of course, new data coming in, people wearing all kinds of things and using their phones and so on, so that we're going to have a lot more data on each person. Not only the genomics, but also everything you do, what you do in your daily routines and so on. All of that could be useful information that we are not even considering right now.
Yeah. And our answer to that is to put a cloud over it powered by Watson, and then we have all the adapters down into those data sets, whether it's an electronic medical record, a genomic set, or behavioral data.
Do you have access to the entire web?
Yes.
Okay. And did Watson, once upon a time at Almaden, there was a project called Web Fountain. There was very early an effort to get the structured information. Right. Does it have any relationship to Watson, or was it just prior history?
No, prior history.
Prior history.
Yeah.
So let me ask Yoshua first. There have been a series of books in recent months that have all sort of suggest we're on the cusp of a jobpocalypse, if I can come up with that kind of a phrase. That this technology is working so effectively that it's going to transform the economy in ways that are perhaps negative as well as positive. Do you? I mean, you've been deeply involved in this. Do you have a sense about the rate of change, and do you have a perspective about what's happening to the economy, or what might happen to the economy if these technologies work really well?
Of course, the potential impact is amazing. And I signed those letters warning that we should be careful on how we're going to be using those technologies and what kinds of rules of the game we're going to be putting together. So when you have such powerful technologies, there's going to be concentration of power, like any new technology has had as an effect in the past. And we have to be careful of, as a society, how we handle that. In particular, I'm worried about military uses of these technologies. And so the second letter was about telling our governments that we should ban the use of AI for autonomous weapons. But more generally, I think we have to think of what are the rules of the game we want to put in with the use of AI techniques as they get better and better. I'm not so worried about the sort of the scenario of superintelligence and sort of the science fiction movie scenario that we see and sort of maybe scares people off. I'm more worried about what's going to happen in the 5 to 10 years from now when the technology becomes more powerful and changes the economy, as you're saying.
Well, so let me, your point about superintelligent machines, let me ask you how you perceive neural nets. Are they biologically inspired, or are they, so it's our best guess on how the mind works?
It's a best guess about the computational principles. There are lots and lots of ingredients, of elements, of details that neuroscientists see in the brain that are completely ignored in those models. So to a neuroscientist, the models we're using are a cartoon. I mean, for them, they have nothing to do with the brain. But of course, we don't know how the brain works. And one of the things that we're trying to do with those models is help us propose theories and ideas that might explain at an abstract level what's going on that explains our intelligence.
Yeah. So, jobpocalypse?
No, I'm not worried, John. The pattern I see as we use Watson across all industries is that in every discipline, every industry, there's a normal distribution of people's abilities, from people who are on a learning curve to the average to the superstars. And it's true whether you're talking about oncology or financial advisors. And what we're seeing very systematically across industries is that it's shifting the whole distribution. So the very best are getting even better. So a cancer researcher at Sloan Kettering is getting even better. They're the world's best, they're getting better. The norm now is becoming equivalent to the very best in the world. And people in places in Asia and Africa now are becoming as good as the norm here because they have access to this. So I'm seeing a whole shift of human capability here in all of these disciplines. And I don't foresee the day where we're going to be displacing that.
Let me pose. I mean, so healthcare is interesting. We've talked about other industries. Our economy after the Second World War, many of the jobs that were created, new kinds of jobs, were sort of people answering questions via the telephone or providing technical support or selling, or being operators. There was a huge explosion of white-collar labor. And then over the last 10 to 20 years, because of telecommunications and the falling cost of computing, call centers, for example, moved overseas dramatically. And now I'm wondering if we won't sort of, because of technologies like Watson, have kind of a Freakonomics sort of effect where technologies that were outsourced for cheap labor come back to the U.S. but to run as software in data centers. Could this technology come quickly enough that...
I guess I think about the challenge in a whole different way. We started out, John, talking about Moore's Law and scaling, physically scaling devices. When you think about cloud data centers, I mean, we fundamentally started to scale systems at a very large level. With these technologies, this is the first time we have ever in human history scaled human intelligence. We are now going to put human intelligence on the equivalent of Moore's Law because it's going to grow as fast as we're generating data because these systems will keep up with that data generation. And we're going to get new insight. We won't be treating an average patient any longer. We'll be treating a very specific portion of a tumor at that instant in time, something which we as humans have no hope of doing.
And where are you in the discussion that Yoshua sort of indicated, the concerns that people like Elon Musk, Summoning the Demon, and others have about the rate of increase of this technology? Do you think that the machines can in some way gain any independence from us?
I have the power button. No. I mean, I guess you could paint scenarios where, autonomous vehicles or weapon systems. But when I stand back and I think about this, what scares me more is what we don't know. What scares me more is the kind of treatment that some people are getting, which we're trying to save a life and we're not saving. Yeah. So the lack of knowledge, the lack of insight, the lack of these tools scares me a heck of a lot more than the existence of these tools.
Yeah. But what are the limits of this technology? So we have this biological capability to understand. These machines are increasingly doing things that look like what we do, whether they are or not. Are you aware of the philosopher John Searle and the Chinese room problem and his critique of the possibility of AI? And do you have a position? Will the machines understand in something akin to a human-like capability at any point?
Well, I mean, it's something that we debate all the time. First we said, well, there's no way we're going to have creativity, and then we created forms of Watson that are creative, whether it's a recipe or, a drug, forms of creativity.
Have you let Watson do art yet? Is it painting?
No. Well, actually, we did one art piece up in Boston, in New York. But it's color. I mean, it basically tears it down to some chemical formula, knows what humans like, and then reconstructs. Whether that's creativity or not is debatable.
Yeah.
And then I think human values is the other, the question is that learnable by a system? And I think that's debatable.
So
you think that's what?
Debatable.
I think it's important because if we want to deal with the scenarios where machines become maybe, as intelligent as us, in order to take the right decisions, we're going to have to sort of instill them with a value system. And it's going to be hard to write the rules of robotics. There's always going to be some ways, some loopholes. So I think the only way this is going to work is by, just like we do to some extent, learn about ethics and moral by looking at other humans, our parents in particular. I think those machines could eventually learn that, and that could guide their actions.
The notion of, a complex task like embedding an ethical model in a machine, do you think that's possible anytime in the foreseeable future?
I think it is.
Okay.
I think it's not feasible to do it in the old AI way by trying to write a set of rules. Just like, any legal system always has holes. And you don't want holes in that case. So I think it's safer to consider a kind of a more soft definition, which is, well, what would humans in general think about this situation? And it's a complex question, but it's something that's I would feel more reassured about.
What troubles me, you raised the question of autonomous weapons. What happens when I design a moral weapon and my enemy designs an immoral weapon?
Well,
how do you get around that?
I think we need to get rid of weapons in the first place.
Yeah. Just a couple more questions. So start thinking of the questions from the audience. I think there are microphones, and so give me just a couple more. Self-driving cars anytime soon?
For sure.
How
Well,
quick?
I mean, we're not working on it in IBM, but I think the technology is there. I mean, it's a system engineering problem at this point.
Yeah.
I think the advancements in
For
AI,
some things, it's there, and it's already almost in production.
Yeah.
But the capabilities are going to grow in the next few years.
Yeah. Well, I think Thursday, Elon's offering self-driving on freeways in limited situations.
Okay.
But I've been telling people that if in 2025 they can send an Uber to me in San Francisco and it can take me to dinner in Palo Alto, I'm buying dinner. I think there are many hard problems that haven't been solved yet in this unstructured driving.
Yeah,
So I agree, and I think with all the excitement we see about AI and deep learning these days, I would advise a word of caution. There are still really important challenges ahead of us, many things we don't understand about the science behind these algorithms and AI. And although I do think there will be a lot of industrial applications and a lot of progress, there are many hard problems in front of us from the scientific point of view.
Yeah.
Yeah, I would echo that. I mean, I think what we have to realize is that we are at an incredible point in time in a transition in information technology here, where, at first we moved from mechanical systems where we put data in through punch cards and things. And then when we had enough internal memory in the system in the late 40s, early 50s, we could put our programs inside the system and let the machine run away going forward. We're now at an incredible transition here, but we're at the very, very beginning of this. I mean, it was a huge step to build, a Watson Q&A system. It's a huge step to build a clinical trial matching tool. But we're a few years into what is going to be decades, I think, John, in this new era.
Let's take questions. Terry, just...
Yeah, Terry Sinofsky. First, a comment about this issue of morals and ethics. I agree completely with Yoshua about the fact that it's a pattern recognition problem, and we human beings learn it from your culture. And there are different cultures in the world. They have different ethics in different parts of the world. You probably know that. And I don't see any problem at all about being able to train deep networks on the morals of your particular culture. The real problem is that there are so many different cultures. So which data to use? Okay. So here's the question for, what is the current market value for Watson?
I hope you don't ask me.
And I'm not being coy here. It's very difficult to calculate that. I will tell you that, it's been we launched it formally as a business in January of 2014. Its growth has been vertical. As I said before, we have hundreds of clients in every industry around the globe. We've gone from English to Arabic to Japanese to French, Spanish, soon Italian. So it's learning languages at a very rapid rate, by the way. It's now a month or two to learn a new language. And not translate the language, learn it and think, if you will, in that language. So, we're on a path to build what we think is the next major platform for IT in this new era. So what kind of value do you put on that? I don't know. I think the future is absolutely incredible for this system.
Next question.
Who's your competitor?
Follow-up question.
Well, as I said, to my knowledge, no one is building a platform. Several companies are investing heavily in algorithms and buying companies to attack specific problems. But to me, that's sort of the difference between doing a one-off and creating a whole industry standard platform like we did with the 360 or we did with the PC. That's really what Watson is going to be. It's not going to be a one-off in one business.
Next question.
Carl Hewitt. I was wondering if you'd care to make a prediction. Where do you think it is that the system Watson might make money for somebody? Which application area do you expect to make money first, and what kind of money might they make?
Well, if you were a large pharmaceutical company and it discovered a new drug for you, the value of that would have a B after it. As you know, most pharmaceutical companies, the failure rate is 97, 98% in drug discovery. If you can move that needle 1 or 2%, or collapse the time of a trial from a decade to a couple of years, the value has a B after it. So now, the cases I gave in healthcare, what value do you put on saving somebody's life? We all know that misdiagnosis is an enormous problem. Financially, it's one of the biggest drivers of downstream cost in the healthcare system. So that can shake billions and billions of dollars. I mean, the healthcare industry is $8 trillion worldwide, $3.5 trillion in the U.S., and most estimates are 20 to 30% of that $3.5 trillion is waste or downstream effects of misdiagnosis. So tremendous value can be had, I think, in every industry, with a tool like Watson. B's and T's.
Hi, right here.
Next
Hi,
question.
my name is Laura Meyer. I do work for IBM, and I'm curious where you see partnerships happening out here. We have Watson West announced. I'm very excited by that, and a lot of startups forming with those AI tools you're talking about. Do you see some specific partnerships or startups that might be good partners or opportunities beyond healthcare?
For Watson, or that's a general?
For Watson, yeah. Or
Yeah, so we just announced last week a big partnership with Thomson Reuters, one of the biggest content companies in the world. And basically, as you know, in many industries, from law to healthcare, they serve up content. They're a huge content publishing company. And they believe that Watson could transform their business by not just offering raw content or human-manipulated insights, but machine Watson-generated insights at high speeds. So the whole publishing content industry could be affected enormously. In retail, not only can we turn Watson on to Twitter feeds and social media, but also look at the systems of record to know, if you're a major retailer, what have people bought, what's available in the supply chain, how do I compare that to what people are chatting about. So we have yet to see an industry. A couple of others that really excite me, we talked before about natural language and vision. I think the whole area of IoT and machine to machine, because we can apply these algorithms, at machine speed. And, think about insulin pumps, think about medical devices that, today they're sort of programmed to the average or what the doctor last saw when you visited him or her a couple times a year. Think about Watson now using machine learning to understand that device and your behavior to alter your insulin pump, as an example. So lots of machine-to-machine capabilities. And then education. There's a lot of analogies between healthcare and education. Just as we treat the average patient with one med,
yes.
we treat the average student with one textbook or one course. I think that education is another industry that is really ripe for disruption, where we'll be able to tailor the education in real time to the student, whether you're a pre-K, whereas a 2 or 3-year-old, one of the tightest correlations between what you're doing or what you know as a 2 or 3-year-old and where you eventually end up through most metrics is the number of words you know when you're 2 or 3 years old. If Watson is there with a preschooler understanding what's going on, I know Watson will be able to teach children language much, much more quickly. And you can imagine the outcomes of that. So every industry we look at, we just see the ability to leverage this cognitive capability and the great technologies that we're getting from these universities. Huge potential.
Hi, my name is Vince. I've used your dialogue module in TechCrunch and built an application in less than 12 hours using IBM Watson.
Great.
And thanks for favoriting the tweet during the event. So my question to
12 hours.
And thank you. My question is, what is your ultimate moonshot impact using Watson? For example, in my dreams, I think to actually incubate Mother Teresa or Mahatma Gandhi. and at age 26 produce that. So my question is, what is your ultimate moonshot impact with Watson? You dream of, or you dream of with or without IBM?
Okay. So, I have two in my mind. One is healthcare. I am absolutely convinced that we are going to change the face of healthcare with Watson. But there's another one which has captured my imagination back at this on education. I am beginning to believe, because we're doing a lot of work with neuroscientists now about how the brain really learns and when it learns. And I'm beginning to think that if we can couple Watson with learning at its various stages, that we can actually accelerate learning dramatically. If we can impedance match Watson with the human as it's learning, I don't know whether we're going to be able to get a PhD in 2 years from 5 years old, but we'll get new students for you.
Great.
But I honestly believe that something magical could happen if we could accelerate learning and really tailor it to the individual at a given point in time, and that will change society in a big way.
Terry Jesnowski out here has a course on learning to learn now. Is that possible, Terry?
Yeah. So, okay. So we have a MOOC. So I have a MOOC with Barbara Oakley that went online August 2014, and now has 1 million learners around the world. It's called Learning How to Learn. And it uses the best, advice on the practical side from educators, but also from what we learned about the brain. We know an enormous amount about the mechanisms underlying many different forms of memory and learning. And I completely agree that this is a fantastic opportunity that we have because of the fact that not just a platform like Watson, but we have an internet that allows us to access millions of learners. I've taught 1,000 students in my lifetime in classrooms, but over the last year I've taught 1 million. What a fantastic opportunity we have.
Here's a question. Oops. Oh. Then there and then there.
Hi, I'm Andy Dietzman. I was just curious on all of the healthcare things, how you're going to deal with HIPAA regulations and any sort of FDA clearance, especially for something that's always learning. How is that going to work with any sort of validation or regulations?
Yeah, well, today these are information systems that are supplying, sources of data, ideas, portraying the data in different ways. But frankly, the FDA is going to have to determine how are they going to treat these systems. Is it going to be a class 1, 2, or 3 device? What sorts of qualification processes we'll have to go through, because these are complex learning systems. They're not a stagnant system that you just turn a switch on. But today, again, we keep a doctor between the system and the patient, and it's basically an IT tool. It's not a medical device. But it's pretty clear to see where this is probably going to go. We're in the, as an example, we are in the process of closing in a couple of days on the acquisition of Merge Healthcare, which is one of the largest holders of medical images in the world, about 30 billion or so medical images. We want to apply Watson to that as a diagnostic tool, and we'll use Watson to train over 30 billion images. It's going to get pretty good.
And I think medical images is one of the low-hanging fruits.
I agree, Yoshua, I agree. So, at the point then we introduce it as an actual medical tool, we'll go through FDA approval for that. And of course, the criteria is that we'll have to be as good or better than a radiologist at that point.
A question for our moderator. John, in your journey to produce your wonderful book, Machines of Loving Grace, you have a particularly unique perspective, having looked across the industry and disciplines. In that journey, what surprised you the most?
Oh, God. What surprised me?
John reacts that same way when I ask him questions.
What surprised me the most? There were surprises. I'm having trouble thinking of them right now. Why don't we take the next question? If I come up with a surprise,
Were you surprised at how long it was AI was going on, research back into the 40s and 50s? Or was that something you knew going in?
No, I knew that this. Yeah. I mean, if it started in the 40s, I knew about the stuff that happened in the early 1950s. No, I guess I'm. What took it so long is kind of the surprise. I mean, it's been. I mean, I can't tell you as a reporter how often this field has actually overpromised. I think if you go to the very first neural net in 1957 or 58, there was a UPI story when Frank Rosenblatt, Cornell, introduced the first neural net. The New York Times UPI story said that we would have a thinking machine in 1 year. And then in 1962, when John McCarthy proposed to DARPA that they fund the Stanford AI Lab, he thought that a thinking machine would take a decade. And after that, it kind of became a constant. It was going to be a decade out, because a decade, there's something really great about a decade in terms of...
It's still a decade.
It's still a decade.
But we didn't have, it's a couple of things, John. We didn't have the data. We didn't have the quantity of data, digital data, for the training. And the second thing we didn't have, and it's, it's pretty simple, we didn't have the compute power.
Right.
Yeah. I mean, when we did the Watson Jeopardy system, that 85,000 watt system, they were brand new, most advanced power systems off our manufacturing floor that hit that lab about 3 or 4 weeks before that Jeopardy show was taped. And we used every processor and every thread and every bit of memory in that system to beat those two human beings. If we were 1 year, 18 months behind on Moore's Law, we would have got killed in that game show. So there is something to be said for raw compute power.
And we still need a lot more, but we are approaching sort of human computational ability in terms of just sheer computation. Like the biggest neural nets we currently have a number of neurons comparable to, say, frogs or an insect, even depending on the size of the models. In terms of the brain size. And so, but that's not so far off from the human brain in terms of size, maybe 100,000 or something like. Yeah. So at the rate at which computing power is increasing, it's with the advent of specialized hardware for neural nets, I think we can easily hope for 100-fold speed up with just a couple of years. Then the rest is going to take more time. But that's only another 100-fold speed up that we need.
Yeah.
There's
wait. I have the mic. So I'll go first. And you've asked 2 questions. It's my turn, sorry. Hi, I'm Elba Linscott, and you'll have to bear with me a little bit. Maybe this will sound a little bit science fiction, but we know that sometimes things that are not possible, that seem impossible, become possible. So if it was possible, what would be your thoughts around Watson having the ability to feel emotions?
Can Watson feel? Would it be possible for Watson to feel emotions?
I'll tell you, Watson has surprised me an awful lot over the years.
It's given you emotions.
It's stirred my emotions. I'm thinking back, some of the early days before that show, when we would ask it questions, and it was like, whoa, how did it come to that conclusion? You know, it was quite a wake-up call. No, I don't think. Obviously, I don't think there's no emotion. There's no self-awareness. Is sort of another question. It's a computer. It's one heck of an intelligent computer in a couple of dimensions, but has no self-awareness.
No.
Oh.
Well, it comes down to the question is, if you believe that anything can be quantified, including personality and emotions, and machine learning gets good enough to quantify that and learn, emotions, then it could start to behave with emotions. But does it really have them is another whole question.
Exactly.
I was going to say the first step, and that's already happening, is modeling human emotions. Predicting the emotions that a human would feel in a particular context. And you need to do that if you want to build good interfaces with humans. If you're Facebook, you want to predict what kind of emotions people will have for a particular post and things like that.
I will tell you that Watson will start to speak with emotion.
Prosody, is that the term in particular?
Yeah. Yes, and it will understand you and what best resonates with you in terms of how to speak to you, and it will adjust to that.
And in terms of sort of speech synthesis and sounding human, how quickly will Watson be indistinguishable from a human?
Today we can make it that way.
Right.
Today, we honestly, when you see a TV ad or when you talk to Watson, we leave some machine cadence in there.
Yeah. To separate it. Interesting.
I have a question for Yoshua. You mentioned ethical systems earlier. What scenarios do you envision a thinking machine requiring an ethical system?
As soon as a machine has to take decisions in the real world and not just answer questions, the questions of values and ethics may become relevant.
But does an ethics mean some sort of power that the machine has that it would require ethics?
As soon as you take decisions, you have power, right? You can take the wrong decision from the point of view of those values or that moral that you think is the thing that matters.
Well, so there's a rich discussion going on now in the automobile industry.
Right.
Cars are moving around in the world. They're going to run into situations where they're going to have to make decisions. And they ultimately, the philosophers say, will be ethical decisions. You'll have to decide whether you want to kill the 2 people and going this direction or move here and kill the 20 people. And that, I think it's framed as an ethical decision already. I think that's sort of the context.
Yeah. There's a whole question of how you want to build the architecture for cases like that, John, because you probably don't want to leave all the intelligence at the edge in the vehicle, in the control system, because it will learn, and it may learn some things that you don't want it to learn or do. Always turn right in this instance, as an example. So there's probably going to develop an IoT architecture with at least a couple of layers where higher levels of learning and direction are going to come from the cloud or for some place that's not at the point of contact when it's a life and death situation.
Yes. Is there a microphone for up front?
I have a mic.
Oh, I'm sorry. I can't see you in the light. No, you're next then. I'm sorry.
Great,
Go
thanks.
ahead.
My name is Tracy Groves. I spend my day explaining economic change. And there's great frustration with the time lag in public economic data and other data sources. I'd be interested in hearing from you, with cognitive systems, what opportunities are you seeing for development of new tools or even real-time data for explaining different aspects of economic change?
Well, so we're working in a number of industries now that are optimizing around different economic conditions. So we're working not at the scale that you're referring to, but we're working with oil and gas industries, all the way from acquisition of new oil fields to optimization of drilling and draining of reservoirs and preserving of underground reservoirs. So looking at the economics, trading off the engineering of how much oil do I pull today out of the ground versus what am I doing to the long-term economic value of that reservoir and that well. So that's an example. We have built and this may challenge some of the people in the room, I know there's a lot of investors here, but we've built an M&A tool version of Watson, which is very good. Understands company profiles on many, many different dimensions and previous success factors, and can start to, pass some judgment on.
What's the interface? How does someone use it?
It's a visual interface, a voice-activated visual portrayal. So, Watson, give me the top 100 companies in California that do this. Bang. Watson, show me companies that have greater than 500 employees, have this kind of return, and, Lucho Lanza is an investor. Boom. So you can then reason over this data very, very rapidly. And so that's another way of sort of playing with some economic factors. So we're going sort of industry by industry.
Will Watson be a personal financial advisor?
It already is with some banks. It's a personal financial advisor, and in some cases, if you're applying for insurance or you're contacting a call center, in many places around the U.S., you don't even know it. You're talking to Watson, or Watson is powering the response you're getting on the website or from the person that's talking to you.
Jaime Carbonell, Carnegie Mellon University. I'm glad that you brought up the education aspect, whether Watson delves deeply into it or you encourage Watson to do so. It's a tough nut to crack, in my opinion, as there's a long history of work in computer-aided education improvement. But some of the aspects that I think are most important are student modeling, being able to understand what the student knows and what the student's misconceptions are that require clarification or require retraining or the like. Do you see this as a personalized form or a form of an intelligence system that really has to acquire a lot of data about the individual that it is teaching? And do you see that the current techniques are good, or you have to go to techniques that would embrace forms of deep learning or other techniques that may not yet be fully wired in?
Yeah, we've built some prototypes for a few school districts in the U.S., which have produced some very interesting results. Not yet fully utilizing Watson cognitive capabilities, but using very sophisticated analytics to get to an N of 1, if you will, around that student. And just by doing that, finding, out of a cohort of 100,000 people, which students are most like that child and what outcomes occurred based on what intervention when, has a first-order effect. Just bringing that knowledge to a teacher in real time. When we add to that, whether it's a MOOC or some form of online or electronic learning, when we add to that Watson's ability to look at the behavior of the student in real time and say, well, Johnny is learning this topic very quickly, but is missing this content or this concept. Stop now, go give him this quickly, and then we can move on in real time. I think it's going to accelerate learning dramatically.
Do you have a comment?
2 more questions.
Well, one thing I'd like to say is that one issue in this case, like in the medical case, is getting institutions to share the data or to collect the data in a single place, again, with privacy issues and so on. So the non-trivial social questions are not just technological questions to make this a success, but the potential is amazing.
Next question.
It's Thomas Van Diarpoor from Geneva. Yes, sounds on. I think related to the point that Dr. made from CMU, I think it's about the data collection part. I mean, Watson doing a great job as a brain, as a processor. But I think if you wanted to personalize it, for example, for education, for healthcare, for whatever, going back to the point that, John, you made earlier about the precision. So if you wanted to have really precision, we need to really find ways to collect the data accordingly. So if it's about students, for example, we need to really constantly be able to train this data set in a fashion that's going to be, very relevant. How about the students changing, etc. For the healthcare, that's going to be a massive challenge. I mean, depends on the type of data that you want to look at. Is imaging data? Yes, there is a banks of data sets that we can apply this for, but if it's going to personalize it, it's going to be. So how we want to solve that problem? Have you thought about, the data collection piece, which is a,
yes.
continuous time?
Yeah. Well, in our case, having Watson and all of the machine learning techniques, analytics techniques, that's sort of jacks are better to open. The real value, as you say, is in the data. And so if just sort of look at the companies that we have been acquiring. We've been acquiring companies that hold tens of millions of electronic medical records or billions of medical images or data that will become critical for Watson's learning and then also an interpretation of an individual. So we have, we're working with a company in orthopedic surgery. Well, we have 500,000 lives of electronic medical records for certain kinds of orthopedic surgery, all of the characteristics of the patients going into the surgery, all of the behaviors coming out, all of the outcomes. That is quite a meal for Watson. It can draw a lot of conclusions from that data. So having access to or owning or collecting enough data for these systems is really important.
Terry, and then
so I think the discussion has been very diverse and impressive, but I would like to channel Marvin Minsky, who is one of the godfathers of artificial intelligence. So I was at a meeting at Dartmouth in 2006. It was the 50th anniversary of the 56th meeting that John Markoff alluded to earlier, which was the kickoff of AI. McCarthy was there and a lot of other founders. And what was remarkable about this 50th anniversary was a retrospective, but it was also looking into the future, was that every single person who got up, in fact, it wasn't just people in vision, but it was also people in language. Every single one said having a large database has made all the difference in the world in terms of being able to solve the problems that we started out, trying to solve. Then Marvin got up. And these were all his former students, right? And he said, "Shame on you. You're all just applications. You've lost the real important problem, which is general intelligence, which is, the ability to understand things from a common sense perspective." And, you had the Toronto problem, didn't you, in Jeopardy? and I think machine learning suffers from that, in the sense that, it's an idiot savant, let's face it. But I think that Marvin has a good point, which is that we're missing something really important, and it's something that goes beyond the domain-specific knowledge that I think we've been very successful at.
I would just conclude that we are not out to build a human mind. We are not out to build an artificial intelligent mind. We are out to build one heck of a system to deal with massive unstructured data to assist humans to reach better conclusions and better insights in seconds versus lifetimes.
So
we're not
rather than AI.
Yeah, exactly, John. That's we're not out to replicate a human in any manner, shape, or form. We just want to build really useful systems.
So I have another answer here. Intelligence...
Maybe you are out to build one.
Intelligence requires knowledge.
And I think Marvin Minsky will agree on that. The real question is where you get that knowledge. And we've tried, well, I didn't, but people in the classical AI research have tried to give that knowledge explicitly to machines. The problem is we don't have even a tenth of the knowledge that is in our brain in a form that we can give to machines. So the only solution, and it's working, is learning. And I think that's exactly how we're going to get machines to have common sense.
To be useful. Final question, and then we'll give the floor to Karen briefly before. Go ahead.
Oh, my name is Michael, FIDA Labs. What would be your advice for a startup which is also tackling the space of unstructured text data and create cognitive value out of that? So what would you be your advice for a startup in that same space as Watson?
Oh, my advice is easy. Get on the Watson platform. If you can develop an application in 12 hours on Watson, that's probably the place you want to do it, rather than go off and start at the university and wait a few years. No, I think that the platforms out there, there's going to be an explosion. We're at a few dozen of these services. It'll be hundreds by the end of next year. It is just a wealth of opportunity. And, we came to the conclusion, even with all of our massive investments in this, in the application space, that probably for every one of our applications, there'll be 1,000 that will be done in the ecosystem. And for us, that's good. That's good for the ecosystem. But get on it, try it, and that is the fastest way to money.
I'd like to thank our speakers for sharing this stimulating, passionate, candid conversation. As a small token of our appreciation for you, we have the Churchill Club speaker T-shirt. Please wear that in good health.
Thank you.
A recording of this program will be available shortly on our YouTube channel, where you can find recordings of most of our other programs as well. We hope that you find that to be a useful resource, and you have been a wonderful audience. Thank you so much. Good night.